In this last part of section 2, we're going to talk about combining normal random variables. So far we've concentrated on developing rules for the means and the variances. What happens if we combine two independent normal random variables? So here we have the x and the y. This was these are just two random normal distributions. Any sum or difference of independent normal random variables is also normally distributed. So if we know both original distributions are approximately normal, then when we add those random variables or we subtract them, we're also going to get a normal distribution. And then the mean and standard deviation of the resulting normal distribution can be found using the appropriate rules for means and standard deviations. So the diameter C of the top of a randomly selected large drink cup at a fast food restaurant follows a normal distribution with a mean of 3.96 inches and a standard deviation of 0.01 inch. The diameter L of a randomly selected large lid at this restaurant follows a normal distribution with a mean of 3.98 inches and standard deviation of 0.02 inch. Assume that L and C are independent random variables and let the random variable D equal the difference L minus C between the lid's diameter and the cup's diameter. Describe the distribution. So remember, when we have describing a distribution, you have SOCs. You can talk about the shape, the center, the spread, and any outliers if necessary. Here we won't be talking about outliers because we don't have a data set. We're just going to do shape, center, and variability. So it tells us before that the diameter of the cup follows a normal distribution, and of the lid it follows a normal distribution. Therefore, the difference distribution will be normal. The center, we're following just the rules. We're subtracting two independent random variables. Therefore, we subtract their centers. So 3.98 minus 3.96 gives us 0.02 inches. Then the variability, remember, whenever we are adding or subtracting random variables, we are going to find the standard deviation by adding the variances and then taking the square root. So we get a variability or standard deviation of 0.0224 inch. So we did A. Part B. For a lid to fit a cup, the value of L has to be bigger than the value of C. Right? The lid has to have a larger diameter than the cup, but not by more than 0.06 inches, because if so, then it just comes right off. It doesn't snap on. So find the probability that a randomly selected lid will fit on a randomly selected cup. So remember, it needs to be no more than 0.06 inches larger, and then interpret the value. So finding the probability that it's no more than 0.06 inches, it also told us, we have the restaurant follows normal 3.9 inches and standard deviation of 0.2 inches. Assume L and C are independent. So finding the difference. So the standardized score for 0, meaning it's the exact same, and then 0.06, it's no more than that. So finding the area under the curve, finding their z-scores, and looking at the table or using your calculator. Here, these are using the standardized scores, 0 and 1. This right here should be negative 0.89. Or you can use their actual values, 0, 0.06, and then fill in the mean, 0.02, and standard deviation, 0.0224. Again, it's going to give us the same value of 0.7765. So now we have to interpret that value. There's about a 77.7% chance that a randomly selected lid will fit on a randomly selected cup.